I'm going to show you how to use the waiting event schema element. Let's get started. Hi everyone, I'm Brian Wachters from Vevort. If this is your first time here and you want to learn about automating, programming, and monitoring in VMware environments, you're in the right place. Start now by subscribing and click the bell so that you don't miss a thing. I'm about to show you how to use the waiting event schema element, but first you might want to take a look in the upper right hand corner. There's a playlist for all the videos in this video series. Okay, let's jump in. As you can see, we are this time going to be taking a look at a schema element called waiting event. And I'll tell you that when I first started trying to use waiting event, I found it a little tricky. I'll explain why, but first, let's go to the lab environment. As you can see, I'm already logged into the vRealize Orchestrator client. I'm going to go to the library workflow section, and rather than just start creating a new workflow, what I'd like to do first of all is to duplicate an existing workflow. You'll see why in a moment, but please notice that I have this workflow called Power VM on or off. I'll show you what it does in a moment, but what I want to do is to use that as the basis of the workflow that we're about to create. So I'm going to go to Actions. Let me scroll a bit so I can see the drop-down list. Actions, Duplicate. So I'm duplicating this workflow. And I will call this one, let's scroll up. So it's using the default name of copy of whatever the workflow is called. I'm going to open it up, and the first thing I'm going to do is change its name to something a little more descriptive. I'm going to call this one Waiting, using waiting event. All right. Next, what I'm going to do is go to the schema, and as you can see, the workflow I've duplicated is actually somewhat advanced. It's not super advanced, but it does some interesting things. So the first thing that this existing portion of my workflow does is it checks to see if what state a virtual machine's in. Is it powered on? Is it powered off? Is it suspended? And so forth. So in order to be able to do that, we have an input called VM. That's a VC virtual machine object that gets fed in to determine power state, so that later on in this switching statement, I can figure out whether I want to go down this path to power off the VM that was already powered on, or if the VM was powered off, I want to power it on, or if I get any other state like suspended or other states, or states like those. Suspended is one that we'd expect, but if we get any sort of state other than powered on or powered off, my switch is just going to simply drop down here. It's going to cause the workflow to blow up. I could enhance that portion of my workflow, but I'm only going to handle these two power states. Now, oftentimes when we call actions that use the vCenter plugin, the very next thing that we're going to do is to call another action that allows us to wait for that preceding action to complete. So if you look at either of these two actions, just randomly picking one, I'll pick this one, they each take a VM as input, but they each return as their action result a vCenter task object. And one of the things that we can tell when a vCenter task object, one of the things we can tell from that vCenter task object is the task done? So for both of these actions, we get a VC task object, and all we're doing in this next schema element is waiting until the preceding task is completed. But we're going to do things a little bit differently in our new version of this workflow. What we're going to do instead, let me resize things a bit here, is instead of waiting for the task to complete, we're going to do two things. One, I'm going to drag in a scriptable task. I'll explain in a few moments what we're going to do with this. And the other thing we're going to do is drag in one of those waiting event schema elements that this video is about. So as I drag in this waiting event schema element and position it right about here, I'd like to elaborate a little bit on something I mentioned earlier in this video, which is that when I first attempted using waiting event, I was thrown off for quite a while. And I think it largely had to do with the name of the schema element. In hindsight, if I could have chosen the name of the schema element, I would have called it waiting on trigger. And you'll see why in a moment. So here's what we're going to do. I'm going to delete this action. Instead of doing the usual action to wait for the previous action to complete, I'm going to delete this action. And let me just reposition things here. I want my workflow to look pretty. There we go. What I'm going to do here, let me scroll so you can see this, in waiting event is I'd like you to take a look at what waiting event needs us to feed in. The waiting event needs us, according to the input section, needs us to feed in something that it's going to stuff into an input variable called trigger.ref. But what that thing is a trigger object. Now, a trigger object is defined by Orchestrator to allow us to do things like use this waiting event schema element. But what is a trigger? Well, to answer that question, what I'm going to do first of all is go over, I happen to have another tab open here where I'm in the Orchestrator client so that I can go into the API Explorer. And let's go explore a little bit by searching for that type of object, a trigger object. So I do a search, and if we take a look here, you'll notice that there are 3 plugins defined on my system, installed in my system, that know what this thing called a trigger is. There's the SNMP plugin, the AMQP plugin, and the vCenter plugin, which I'm going to focus on in this video because vCenter is quite likely more familiar to you than the Simple Network Management Protocol plugin or the Advanced Messaging Queuing Protocol plugin. So let's zero in on vCenter plugin and see what it knows about this thing called trigger. So if we expand vCenter, objects, we end up seeing a whole bunch of objects, but I'm going to jump straight to the one that I really want to show you, which is the one down here called, I'm getting there. There it is. There's this object type called VC::task. By the way, feel free to join me in submitting a feature request to get this list of items in the API Explorer to be alphabetized. But I've already jumped to what I'm looking for here, which is this thing called VC::task. A VC::task is defined by the vCenter plugin to keep track of tasks that we're running over in vCenter. So to explain that point, let me pop over briefly here. I happen to have another tab open where I'm logged into the vSphere client. And you'll notice that I just recently completed a task in which I created, by cloning, I created a new virtual machine called, here it is here, this powered off VM called Photon OS. But this was a task. Over in Orchestrator, this thing here called a VC::task keeps track of a task that you ordinarily see in the vSphere client as in that recent task section. So just like the recent task section in the vSphere client shows us things like, is the task done or not, or what's the task called, all that information that we see over in the vSphere client about a task, and even more information, is stored in this thing called a VC::task. But more importantly, for our current discussion, these VC::tasks don't just have attributes like the name and the state of the task. The VC::task objects also have a bunch of different methods that allow us to do things to the task. For instance, just scrolling down a bit here, one of the tasks that we can call is this one called cancel task. Cancel task, if we call that method on a VC::task object, would allow us to cancel the task. In other words, by doing so in Orchestrator, we could do in effect the same thing as coming over here and canceling the task manually in the vSphere client. But back to the API Explorer, the cancel task method is not the one I came here to show you. There's actually two methods I came to show you. One is this one here called create trigger, which if you read it after this video, you'll find it has a bunch of different inputs, but it returns something called a trigger. But I'm not going to use this method as my example for this workflow. I want to work with a simpler example method, which I'll show you in a moment. But this one that we're looking at now, called create trigger, takes a VC::task object and allows us to convert that into something called a trigger. Now, to really understand the trigger, let's go look at the other method called, down here on the bottom, there's a method called create end of task trigger. If I call that method on a VC::task object, then it returns a trigger that I can wait on. Again, over in the orchestrator client, actually let me go over here, over in the orchestrator client, this, in my opinion, slightly misnamed thing called waiting event will wait on the trigger. So what we're going to be doing in these two schema elements is we're going to write some JavaScript code in this scriptable task that takes the VC::task that this action or this action returns. We're going to take the VC::task object and use the code that we supplied here to convert that task into a trigger that will tell the waiting event schema element to wait for. So the waiting event schema element is going to wait for the trigger that we create in this scriptable task from the VC::task that we get from the preceding actions. If that doesn't make sense, rewind the video about a minute and just keep playing that video again and again and again, and hopefully it'll make sense. If not, leave me a question down in the comments and perhaps I can explain it a different way. But we're going to take the VC::task object, feed it into the scriptable task to convert it into a trigger, and then we'll feed the trigger into the waiting event task. So let's give this, actually before we deal with the code, back to the API Explorer real quickly here. The method called create end of task trigger is going to return that trigger object that we need to feed into the next schema element. But notice that create end of task trigger allows us to pass in a single value, which is a timeout, which allows us to say, that it's called timeout, but if recollection serves me right, it's not really a timeout, but rather it's a polling interval. We specify a number, and that's going to specify how frequently the vCenter server is going to check to see if that task has ended. So rather than continuously sit there asking, is the task done yet? Is the task done yet? Is the task done yet? The timeout value allows us to set up a polling rate. So for instance, wait for a minute until we check again to see whether the vCenter event, the power off or the power on is completed. That's what this timeout value is about. So now that we know about create end of task trigger, which is a method we can call on a VC::task to get a trigger created out of it, we can now go to our workflow. We'll go to the scriptable task. We'll give it a better label. Right now the label is scriptable task, but I'm going to change that to something else like create trigger. If I wanted to be real explicit, I could say create trigger from the VC::task object. Speaking of VC::task object, we're going to feed in to the scriptable task the VC::task object that we received either from this action or this action. So we'll hit add. We'll scroll down a little bit here. We'll click select variable. And we already have, I have to look for it though, we already have a variable that's the right variable here. To show you which one it is, again, remember that what we're looking to feed in here is the VC::task task object that either this action or this action returned. So we're looking for VC colon task. And here it is here. Now it's gotten truncated here. You can't see this, but this, if we were to look at the whole thing here, is VC colon task. I created in my workflow a variable, an attribute called power operation task. It's a VC colon task object. I'm going to feed it into the scriptable task by selecting it. Now, to prove to you that that is in fact a VC colon task, well, first of all, it has to be a VC colon task or I couldn't have not have selected it. But to really prove to you that power operation task is a VC colon task, I'm going to quickly go over to the variables tab. We're going to find that variable, and sure enough, it is a VC colon task object. So we've fed into create trigger, the scriptable task, the VC colon task object that it needs so that we can find that VC colon task object's method to create the trigger. So we'll select the scriptable task. We'll go over to the scripting tab. Here's what our code's going to look like. So on line number 1 of this JavaScript code, I've used the keyword const to create a variable, but it's not going to be a variable that I can change the value to. Instead, it's going to be constant. It's going to be a read-only variable called timeout, which I'm setting to the value 60. And again, this is the timeout that we saw in the API Explorer a few moments ago, which to me isn't really a timeout. It's more of a polling interval. We're going to poll. We're going to tell vCenter to poll once a minute to see whether the power off or the power on task is completed. So we've got our timeout value, and now what we're going to do is take that power on operation task input that we just supplied. Again, it was a VC colon task object. We just saw in the API Explorer that that type of object has a method called create end of task trigger. We're going to pass in that timeout, that polling interval that we specified just a few moments ago back on line number 1. And what that method, create end of task trigger, is going to do is return a trigger object, which we're going to stuff into this variable here called task trigger. Now, if I just leave this as it is, task trigger is a local variable in the scriptable task. And therefore, the only schema element that can see task trigger right now is this scriptable task. But I need to pass the value that we're sticking in this variable to the next guy. So what I'm going to do next on create trigger is I'm going to, in addition to the input that I set up, I also need an output. So let's create an output. This is going to be a new one if I haven't already created it. Let me see if I already have one. I forget if I've set one up. We're going to create a new variable, formerly known as an attribute, called, I believe we just saw it was called task trigger. And we should type a description, but I'll save us a few moments here. And this is going to be a task object, a trigger object. So we choose trigger. And since we're going to programmatically set the value, we're not going to bother to set it here. Instead, we'll just click create. So now our scriptable task has an output called task trigger that we're going to be able to receive in the next schema element by setting up parameter binding. So I'm going to do one last thing here. I intended to call this schema element create task trigger. That's the way I have named that scriptable task in my package that I'm making this workflow available through. So I'm going to simply change the name to create task trigger so that it matches in the package. Okay, so the next thing that we're going to do is go over to waiting event. And as you can see, waiting event has the usual fields up top here, but we're going to jump straight to inputs. And as you can see, it only requires one input, which is the trigger that we're listening for. So this workflow that we're writing is going to wait right here until it hears that trigger firing. Now again, whether you want to call it a trigger or an event, I think of it as a trigger, doesn't matter. That what matters is that we need to pass in that trigger that we just created in the previous schema element. So by performing binding, I'm going to select waiting event. I'm going to go to inputs. I'm going to go to its trigger.ref input, and I'm going to select let me scroll down so we can find it. Actually, it's right there, the task trigger that we set up. So now, if everything's good, I should be able to save it. I should be able to, yep, there we go, save it. I should be able to validate it, cross your fingers. Looks like we've got some warnings. So we've got some task result that's never used, log, task, and so forth. These are actually, if I recall correctly, some variables that are used in earlier parts of the workflow. They're not related to what's going on here. And since they're just warnings, shouldn't cause us any problems. So since those shouldn't cause us any problems, let's go just real briefly, go check in vCenter. Notice that the Photon OS VM is powered off currently. But if we go over to our workflow and run the workflow, we will select the VM whose power state we want to change. So I'm clicking here to search for the value. Actually, I've already set up this workflow. Instead of having a tree browser, I've set this workflow up so that instead of using a tree browser, it uses a search field here. So if I happen to know the name of the VM I'm looking for, I can just type a portion of its name and select it. If you'd like to know how I did that in the Workflows Input Forms tab. But I'm going to select the VM in question, Photon OS. Remember, it's powered off. I'm going to run the workflow. And if we watch real closely here, since it's powered off, it should go through. It went so fast you can't see it. However, I did some logging in the schema element. The schema element should announce, let me go to the logs, should announce that the VM's powered off. So that means we went down this path. And therefore, we called the action to power on the VM, and we created from the vc::task a trigger object. And if I'd been a little faster, you can rewind the video, and I'll prove it to you if you rewind the video. But it was hanging out here on this schema element until vCenter triggered to indicate that the in this case power on action completed. And once that was done, we're done with the workflow. Now again, that took a little bit too long looking in this logs tab to see that actually occur. So let's run this workflow one more time. So right now, Photon OS is powered on. We're going to run the workflow again. Let's see, run again. Same VM, the Photon OS VM. We'll click run. And watch the schema real closely here. Watch for the highlighted schema element. So it runs the workflow. There it is, calling power on, and it's waiting at waiting event, or as I think of it, it's waiting for the trigger. The trigger triggered because that power on action that we kicked off returned a vc::task object that we passed into the next schema element so that we could convert that vc::task in effect into a trigger that we're listening for in the waiting event schema element. So that is how you use waiting event. Again, if you learn nothing else out of all this, think of the waiting event schema element as the waiting trigger. One last thing, I'll remind you, if you understood all that, you're probably going to want to go to the API Explorer. And instead of just looking at the objects in vCenter that can be used to set up triggers, if you, in your IT environment use SNMP or AMQP, you can set up triggers for those plugins too. So for instance, for SNMP, we can say for SNMP, let's find its trigger method. Actually, it doesn't call, if I recall correctly, it doesn't call its method trigger something or another, but it has a method that returns a trigger object. So that's what I'm looking for here. Returns SNMP result, returns, here we go. So we can call this method, which is going to return one of those triggers, but it's going to trigger for any of the devices associated with this, what's OID stand for? Organization ID. Or slightly further down in the list of triggers, if we're using SNMP in our environment, but we want to listen for a trigger on a specific device, we can set up a trigger to listen for a trap coming from a specific SNMP device using this method. Or alternatively, in your environment, your IT environment, if you're using the advanced messaging queuing protocol, for instance, if you're using VMware's Pivotal RabbitMQ product, AMQP has its own trigger for both subscriptions and the broker. But again, they have their own, here we go, trigger returning method so that we can listen on the AMQP bus asynchronously for, hey, is that AMQP message I'm subscribed to, has it been seen? Again, I'll leave it to you to learn SNMP and AMQP if you don't know about those. But these three plugins, SNMP, AMQP, and the vCenter plugins, all support triggers, and any plugin that wants to can support triggers, but supporting triggers is not something supported by every single plugin. The plugin developer has to add code to support these things called triggers. Join me in the next video where I'll show you how to use the schema element called Wait Until Date.